On the left-hand side of my screen, I have a file called merge.js. Inside that file, I export a single function called merge.json. I also have a file called merge.test.js, and it passes two mock user objects, user1 and user2, into our merge.json function and logs the results. I'm going to run this file continuously on the right-hand side of the screen by typing watch-in.5-t node./merge.test.js. This shows the current results of our merge function, which right now just returns the main object that you pass in. We'll start by looping through the source object by typing for let key in source, and for each entry inside of source, typing obj key equals source key, thereby copying each item in source onto the object. You'll see what that result looks like. Basically, all of the items from user 2 got copied on to the object of user 1. That makes for an effective assign method, but we need to actually merge these two together. So it's going to get a little bit more complicated. To handle that additional logic, let's make a function called replace value. And that's going to take two parameters, the current value and the new value. Instead of assigning object key directly to the source key, we're going to assign it the results of replace value, current value and the new value. For now, inside of replace value, we'll simply return the new value. The first special case we want to handle in our replace value function is arrays. Arrays need to be merged together, not simply copied over. We can do that by checking if both the current value and the new value are arrays. Type if array.isArrayValue and array.isArray new value. Once we know that we're dealing with two arrays here, we have two options for merging those arrays. The simplest is to simply concatenate them. You can type return value.concat new value. And you'll see over here that now the interests show up as gaming, water polo, horses, and bunnies. All of them are now included. An alternative way to merge the arrays is to loop through each item in the array and merge the values individually in a recursive manner. That looks something like this. Return new value.map. So for each item in the new array, we're going to take the value and the index. And for each of those, we're going to call the same replace value function recursively with the current value at I and the new value, which in this case is val. Now for our particular use case over here, we now only see the new interests, horses and bunnies. But in more complex use cases, such as nested objects, this will actually combine those nested objects together in more complex ways. And this is the approach used by Lodash's merge. So we'll keep it for now. The next case that we need to handle is object literals, such as our links object. We want to combine those together so that all the links are shown on the screen, not just user 2's links. So in order to do that, we need to detect those. So we're going to create an isObject function. Type function isObject. This will take in an object we'll call obj. We can say return obj and obj.constructor triple equals object. With that isObject function, we can now put in an else up here, isObject value and isObject new value. If both the existing value and the new value are object literals, then we're going to recursively crawl through each key in that object and replace the values just as we did up here in merge.json. In fact, we can call merge.json on value and new value to make that happen. So as soon as we save that, you see over here, we now have blog and Facebook links showing up because our objects are merged. Now there's one other case that we might want to handle, and that's when your source object has a null or undefined value in it. Let's say interests here is null, and in my opinion, we don't want to merge that over. So in this case, we can say right here, if source key equals null, that'll also account for undefined, then continue with the loop. And that way our existing interest won't be overridden with an undefined or null value. Now this is all we need to get basic merge working. There's only one major feature that I think we also need to bring over from Lodash, and that's the ability to support more than one source object. So we now currently support one object, but what if we wanted to have a third user and we wanted to merge these three users together? So users 1, 2, and 3. Right now we just simply ignore the third user. How can we account for that? Up here we'll turn source into a rest parameter called sources, which will combine multiple arguments into a single array. We can make a new for loop for let source of sources. And for each of the sources that we have, we'll repeat the same process until from left to right, we've copied all the sources into our object. In a file called debounce.html, I have two input fields, input normal and input debounced. In debounce.js, we have them both hooked up to a single log event, which ensures that anything I type into the field will be logged on keyup. Here's an example of how it works. Let's add debouncing to the second field to ensure that logging only happens after a short pause in typing. Create a function called debounce that takes two parameters. The first parameter is the function that we're going to debounce, and the second is a wait period in milliseconds. Inside this function, type let timer to initialize a new variable called timer and return a function. Inside the function, type timer equals set timeout function wait. Our debounce function will execute after wait milliseconds. Let's go ahead and clear that timer as well. If timer clear timeout timer. Essentially that will cancel out any functions already lined up to be called. So now our function will only be executed once, wait milliseconds after we stop calling the function. We now need to handle the arguments that get passed into our function, such as the keyUp event that gets passed into log event. To do that, we're going to use a REST parameter in our function signature, type ... args, which will put all received parameters into an array called args. We can then apply that into our set timeout function using an arrow function, and then spreading those received arguments into our function call. This is essentially debounce right here. Let's go ahead and wrap our log event method in debounce with a wait time of 300. We'll save that, refresh our page, and you can see once again on the left-hand side, it logs every single key press. Over here, it should only log when I stop. And it looks like it works perfectly. On the left-hand side of the screen, I have a file named debounce-maxwait.js. In it, I have a simple debounce function, which is hooked up to the input field on the right. If I pause briefly while typing into the field, its contents are logged. But now watch what happens when I type continuously into the field. Nothing. To address that, we're going to add a maxwait option to our debounce function, similar to the one found in Lodash. First, use destructured parameter syntax to add a maxwait option. Then define a max timer variable. With that in place, below our first timer, type if maxwait, max timer equals set timeout. And this is going to look identical to our first timer, except instead of using wait for the amount of time, we're going to use maxwait. We now have two competing timers, max timer and the initial timer. Let's clear the other timer within each of these. Clear timeout, timer, and in the first, clear timeout, max timer. Clearing those timers basically ensures that both timers aren't triggered right after another. Now after your clear timeout of timer, type max timer equals null. And on our if statement, we'll say if maxwait and not max timer. Essentially what we're doing here is preventing this timer from being set more than once at a time. Once the timer actually fires, we'll go ahead and set it to null, and then on the next key up, it will be set again. We also need to add max timer equals null in our first timer, and that's so that after we clear our timer, we make sure that it's reset again the next time key up is pressed. With that in place, we now have the ability to ensure that our logging happens even while we're continuously typing. Let's go ahead and update our debounce call now to add that third option, max wait. We'll pass in a value of 1000 milliseconds, equivalent to 1 second. So as I type in the field, you should see that it continually logs every second. Here we have two files, get.js and get.test.js. Get.js exports a single function, a get method, and get.test.js has some sample data that we'll use to test our function, including this data object that has arrays, objects, strings, numbers, and booleans all nested together in a complicated way. The tests we have running are output on the right-hand side of the screen, where the output of our method is compared with the output of Lodash's get method. Back in our get.js function, take note of the parameters. First, we take in an object, then we take in a string, which is the path, and then there's a default value if we can't find the path that we're looking for. To get started, type const parts equals string.split and pass in a regular expression with a character set featuring open bracket, close bracket, and period, all escaped with the backslash. If we log that parts array, you can see that we're splitting up the string into the various keys we'll need to traverse our objects, such as collection, 2. One thing you might notice, however, is that there are a number of empty strings in our array. And those are caused when we have two of our separators next to one another, such as close bracket and period. We can handle that by typing .filter x arrow x to filter out any falsy values such as empty string. Now type let attempt equals obj. This variable will keep track of our attempts to traverse the object. We'll do that with a for loop. Type for let part of parts, and inside the for loop type attempt equals attempt part. And let's go ahead and return our attempt instead of the object. Now you can see that more than half of our tests pass. And in fact, this for loop is really the magic of the get method. We loop through the object until we find what we're looking for. But what if we can't find what we're looking for? For that, we need an if statement. Type if attempt double equals null, return default value. And that actually handles almost all of our test cases. If we're looping through our object and at some point we get to a dead end, we hit null, then we know something's wrong and we need to return a default value. There's one other situation where we're going to return a default value, and that's if we hit undefined. We never actually want to return undefined explicitly, so let's check for that too. Type or attempt part triple equals undefined. And with that, we have Lodash's get method created in less than 10 lines of code. On the left-hand side of the screen here, I have a data structure with nested arrays, objects, Boolean strings, and numbers. Below that, I have several examples of using Lodash.get, which we'll replace with optional chaining syntax. For the first example, I'm going to look at accessing nested objects and arrays. Here are 3 different examples of using Lodash.get to access this H2O molecule deeply nested in our object here. Let me log the results. You can see that for each of these, the results are the string H2O. Let's reproduce that with optional chaining syntax. Type const molecule4 equals data.collection question mark dot square bracket 3 question mark dot nodes question mark dot molecule and log the result. When I run the command, you can see the result was exactly the same as what was provided by the Lodash methods. Let's move on to accessing properties with strings and variables. Here we have 2 different examples of accessing properties with strings and variables. In this, we're accessing the max temp variable found inside of our node object. And we do so with the max temp property accessor here. And then below that with a variable called key, which has the variable max temp. If I log that out, you can see that both temp1 and temp2 are the number 100, which is correct. To recreate this with optional chaining syntax, type const temp3 equals data.collection question mark dot square bracket 3 question mark dot nodes question mark dot square bracket key and log that. And when we run the command, our result was exactly the same as what Lodash had. Now to do the same thing with the string accessor, you can create temp4 and instead of key, put max temp as a string inside of this square bracket notation and log that. And once again, the result's exactly the same. Now let's look at looping through an array which may or may not exist. To do that in Lodash, we will grab an array, and if it does not exist, return a default value of empty array. We'll save that to a collections variable and then loop through that collections variable and log each item. The results of that are a list of every single one of the collections in our data structure. Let's go ahead and reproduce this with optional chaining syntax by typing data.collection question mark dot for each and then pass in the same logging method that we did above. Let's log that. You see that first we log with Lodash and then we log with our optional chaining. The cool thing about this is that we didn't need to save a variable the second time around. We were able to access the for each method on collection simply using question mark dot. And if we go up to our collection and rename this to collection123 and rerun it, you'll see that no errors are thrown. It's a completely safe way to execute a method on an object, even if that object may not exist. And for the last example, I'd like to go over providing default values when a value is not found. For these, we're going to look through the second collection, the fourth collection, and then the has details property of collection 3. Let's log out what this looks like now. You'll see that collection 2 is null, and so instead of providing a default, it just returns null. Collection 4 was undefined, so that is replaced with the empty object we passed in. And then has details is false and correctly returns false instead of the true default which we provided. Accessing the data with optional chaining is easy. Let's do that now. Type const col2 equals data.collection question mark dot square bracket 2. We'll do the same for collection 4 and for has details. Const has underscore details data.collection question mark dot square bracket 3 question mark dot has details. And let's just log those to ensure that we got them properly. And you can see that it's null, undefined, and has details is indeed false. Optional chaining itself doesn't provide a mechanism for providing default values, but there are two options. The most common one is to use the OR syntax, and we'll do that first. Put call to OR empty object, call for OR empty object, and has details or true, which is the default. Let's log that. You'll see here that the results are fairly different from what we had before. Collection 2 shows an empty object instead of null. Collection 4 shows an empty object correctly. And for has details, we get true instead of false. Now, why is that? Because if the OR operator encounters any falsy value on the left-hand side of the operator, it will return whatever's on the right-hand side. So if it's an empty string, undefined, null, the number 0, any of those things will return your default value. Now that works fine if you're expecting an array or an object, but if you are expecting a Boolean which may be false, you can't use OR. Instead, you need to use something else. There's another operator which is new to JavaScript called the nullish coalescing operator. And it looks very much like the OR operator, except instead of 2 pipes, it uses 2 question marks. And with the nullish coalescing operator, it only will return the value on the right-hand side of the operator if the value on the left-hand side is null or undefined, which is actually what we want in most cases, even if it doesn't exactly match what Lodash was doing before. Here I have a cat image following my mouse pointer and a counter which shows how many times we are updating that location. On the left-hand side of the screen, I have 2 files. One called throttle.html, where I create the HTML elements for the kitten and the counter, and another called throttle.js, where we have this mouse move listener on window, which updates the X and Y location of the cat picture using the CSS transform property. We also report how many times our handler has been called with our update count function. Now, as you can see, this works okay, but you can also see that this counter has been updated a tremendous number of times. And especially on lower power devices, this is likely going to be a problem. You'll end up with choppy graphics, or other event handlers may not be able to respond very quickly or at all. Let's fix that problem with a throttle function. Underneath our event listener, let's add a throttle function that takes 2 arguments. A function, which we'll abbreviate as fn, and time in milliseconds. Inside that function, we're going to create a variable called isWaiting, and we'll initialize that to false. Now let's return a new function. And for the arguments, we're going to use a rest parameter, which will put all the arguments into an array. Inside of that function, we'll check if we are waiting, and if so, immediately return. And then execute the function with the provided arguments. And after we call the function, let's set isWaiting equal to true. And then for the key part here, we're going to set a timer. And inside of that function body, set isWaiting to false. And set for the time period, the time passed into our function. When we pass a function and a time into throttle, it should return a new function, a throttled version of that function. And what that throttled version will do is it will only call our function once in the allotted time period. So we have this check for isWaiting, which is going to basically say if you've already called your function, then wait for that timeout to complete before we call it again. Let's see how it works by adding throttle to our event handler. So I'll type throttle and pass in on mouse move. And let's use for the time 200 milliseconds. So it should update 5 times a second. And let's see how that looks. Now, it's certainly choppier than it was before, but you can see our kitty's moving around just fine, and our timer is not updating nearly as often, which is exactly what we want. In a file called pick.js, type function pick, pass in 2 arguments, obj, and the second one is called keys. Inside of that function, create a result object and return it. Const result equals empty object. Return result. Now in between those 2 lines, type for let key of keys, result key equals obj key. Instead of a for of loop, you could have also used keys.forEach here. To demonstrate that the pick function works, we have an object here with the first few letters of the alphabet called obj. Type console.log pick obj and then pass in the array, and let's just give it b, a, d. And if we run that program, you can see that it returns an object with the B, A, and D values. So that's a super simple way to write pick. Let's do it another way. I'm going to comment this out. And again, type function pick, obj, and keys. Now let's create our result object and return it. But this time, instead of looping through our list of keys, we're going to loop through the entire object and check individually if we should include that key in the result. So for this one, you can type for let key in obj. Notice that we're using a for in loop now instead of a for of loop because we're dealing with an object instead of an array. And for this, we'll say if keys.includes key, result key equals obj key, and return the result. Log it out the same way as we did before, and it looks like it works correctly. When would you use this instead of the initial one? Well, usually your object might have many different keys and the keys array might be, a smaller list. So in general, looping over the shorter list is better, though in most instances, the difference is pretty inconsequential. There's one other thing I want to demonstrate here, and that is the ability which the Lodash pick version has of accepting the list of keys either as an array or as individual items in a list. If we pass this in right now, it is going to get confused and only filter out the first one that you pass in, but we can actually handle this property. So let's do it. Go ahead and change the second parameter from keys to a rest parameter. Type ... keys. That's going to give us the ability to basically put any additional arguments that come after the first one into an array called keys. That works pretty well, except if we have a single argument, which is an array. Let me log it out right now just to show you what it looks like. So right now I have an array, and inside of that array is the array that I passed in. If we type keys equals keys.flat, this will flatten our array. And you can see our result is correct. And whether we pass in an array or pass in individual arguments, it's all processed and handled correctly. In a file called omit.js, type function omit, and pass in two arguments, obj and keys. The first thing that we're going to do inside this function is create a shallow copy of our object by typing const result equals object.assign empty object, comma, obj. And we'll return that result. Now just before our return, let's loop through our keys by typing keys.forEach, key, and then for each one of those keys, delete result key. We start by copying the object, then we go through each of the keys we don't want in our object and delete them from the result. Pretty straightforward. So let's create a second omit function, this time called omit2. It'll take the same arguments, obj and keys. And then inside of that, we'll create an empty object for result and return the result. Right before our return statement, type for let key in obj. And then if not keys.includes key, result key equals obj key. So for each of the keys in our object, we're going to loop through those. And if the key that we're currently looping through is not included in the list of keys, then we'll go ahead and copy that over into our result object. To prove that this works, I've got an object here with a few letters from the alphabet, and we'll test against that by typing console.log omit obj, and we'll pass in the array b, c, d, and we will do the same thing down here for omit2. So let's run that. node./omit.js, and we're seeing exactly right, only the A and E keys remain. In a file called filter.js, create a function called filter that takes two arguments, obj and a function which we'll abbreviate as fn. Inside of that function, type const entries equals object.entries obj, and go ahead and return those entries. I also want to start logging the output of the function to demonstrate how it works. To do that, I'm going to bring in a sample object here, which contains a couple letters from the alphabet. Let's run that now. You can see here what is logged is an array of arrays. Each key and value pair from our object has a corresponding key and value pair array inside of the entries array. So object.entries converts an object into an array of tuples. These short arrays that contain just a key and a value. Let's bring fromentries into the mix by wrapping our return of entries in object.fromentries. And when we run that, you'll see we have our original object back again. So entries will convert an object into an array. Fromentries will convert an array in this particular format back into an object. Well, this becomes very powerful when you combine that with the built-in array functions, such as filter. Let's pass in our function here to filter on the entries object, and now we can use that to create additional functions, such as omitby and pickby. We'll comment out our existing log for now. Below that, type function omitby, pass in the same arguments as above, obj and function. And inside of that, return filter obj. We'll use arrow function syntax here. We'll call our parameter entry, and we will pass that value to our function like this, entry 1 and entry 0. The omitby function takes the value first and then the key. The last thing we need to do is put a not in front of our function. We're omitting these things, so anything that matches here will be excluded from the output object. Let's log that out and see how it works. Console.log, omitby, we'll use the same obj as above. For our function, we'll use an arrow function, which takes a value, and we will simply say value greater than 2. So let's run this, and you see that any of our entries in the object that has a value greater than 2 are excluded from the output. Now I want to write this in a slightly more concise syntax. There are a couple of tricks we can use to do that. First, we're going to start by using arrow syntax on the function itself. Type const omitby equals, as parameters obj and fn. Then we'll return the results of filter, pass in the object, and instead of having entry as the parameter, we're going to use destructuring syntax, and we'll split this up into key and val. So this is our second arrow function, which is going to call not fn, val, and key. We're taking in these two parameters, we're actually flipping them when we pass them into our function, and that's omitby again. Let's comment out the version from before. We see that it still works the same way. And from this, I'm going to copy and paste it, and we're going to create pickby. Pickby is the exact same thing except for excluding anything that matches. We're just going to include anything that matches. Let's run pickby here with the same value greater than 2 parameter. So you see our first result showed anything with a value of 2 or less. The second one kept any entries that were greater than 2.